Hi everyone, I'm Hareram, and today I am sharing a real world case study on building silent cross cloud analytics pipeline with Azure Databricks with more than 10 TB daily scale. You'll hear exactly how we combined SRE discipline with Delta Lake optimizations to keep strict SLAs while making performance predictable and keeping the costs sane. For context, think billions of events per day, multi region ingestion, and user facing dashboards that must stay fresh within minutes. So, here's the flow for the next 12 to 15 minutes. So, the first, I'll discuss the architecture and where the cross cloud seams are. And second, the reliability engineering we enforced. Third, the performance work, especially Delta Lake and Z order. Fourth, our incident playbook and how we shrank MTTR. And finally, a practical blueprint to that you can adopt. And I'll anchor each section with the concrete thresholds and examples so you can relate to them. So our challenge was ad campaign in telemetry in double-digit terabytes per day. So, with many interdependent ETLs, a single upstream blip could cascade. The business expectations were blunt. So, real time dashboards, historical trends in minutes, cross cloud consistency without wasteful duplication, and predictable performance even when the load is spiky, without blowing the budget. And we set the working target of P95 freshness less than 15 minutes and P99 less than 30 minutes with back pressure rules when these numbers drift. So we deliberately cross clouded, not to use everything, but to pick the best pieces and define hard contracts at the seams. Three principles guided us. One, data locality and replication across regions and providers for HADR and latency. Our DR RPO targeted single digit minutes and RTO under 1 hour. So two standardized APIs and OSS. So Spark or Delta are lingua franca and provider bugs are hidden. And the third is unified observability. One place to see metrics, logs, and traces across clouds. So detection and response are fast. Every alert ties to an explicit SLI and a runbook. Concretely, our stack looked like this. So we had Azure Databricks for Spark for compute, paired with Delta Lake for asset semantics, absurd schema in evolution and time travel. And Azure Data Factory orchestrated dependencies, retries, and monitoring with jittered backoffs. Amazon S3 provided durable versioning storage where we needed it for landing curated zones. Around those, we added reliability layer. These were like the circuit breakers, bulkheads, and the boundary isolation. So a cloud specific issue is on top, a performance layer which had this Z order and partitioning aligned to access, small file compaction, dynamic allocation, and finally an operational layer run where we had the runbooks, automated remediation, and blameless reviews. Every handoff writes checkpoints, and the stage can resume without reprocessing. And we ran this like a product using SRE. So we tracked SLIs on three things: the freshness from the ingest to the gold availability, P95 query latency for key workloads, and end to end success rate. We set error budgets that triggered graceful degradation for reliability slip. For example, pausing non critical enrichments if the 7-day rolling P5 freshness exceeded budget. So, post incident, blameless reviews drove systematic fixes, and we attacked toil first, like automating the top recurring failure classes so humans aren't babysitting pipeline. Our goal was to keep auto resolution above 70%. To make failure safe, we standardized 4 pipelines patterns. Checkpointing, so every stage can resume from known offsets. Offsets are committed only after idempotent writes succeed. Circuit breakers at integration points, so we stop cascades when freshness drifts and or dependency fail repeatedly. For instance, Trip if error rate is greater than 10% for 5 minutes or if the freshness breaches persists for 3 consecutive checks. Exponential backoff with jitters. Retries do not create stampedes and random jitters were up to 3 seconds. And idempotent write-offs, replace never corrupt state. All mergers are keyed and we avoid side effects on retry. In short, retries only work when your operations are idempotent. And then performance was the other half. Before tuning, we had full scans, big shuffles, and spiky latencies. And we aligned storage to actually access patterns, partitioning that prunes, for example, by event date, and reordering on high selectivity keys used together. Think campaign ID, region, and device type. So we kept metadata lean with optimize and small file compaction. So Spark wasn't drowning in tiny files. The result, drastic input output reduction and complex queries dropping to minutes or even seconds with stable P95 and cache hit rates improved and shuffle spill decreased meaningfully. Practically, how did we choose C order keys? We mined query logs to find the most frequent multi column filters with high cardinality and low overlap. We validated with A or B runs and representative workloads and revisited keys quarterly because access patterns shift with new features and dashboards. And we also capsize the order frequency to avoid consistent reclustering. So typically weekly for hot tables, monthly for warm ones. We also tackled cost without sacrificing reliability. We abandoned fixed clusters and moved to workload aware auto scaling. Inputs included priority tier, incoming volume, queue depth, SLA proximity, utilization, and hard cost guards like max nodes per tier. That combination kept clusters right sized, cut ideal burn, and preserved predictability. The side effect, far fewer capacity pages. Engineers focused on data quality and features. When nearing an SLA breach, we temporarily allow burst scaling, then decay back to steady state. Incidents still happen, and our response life cycle is 5 steps. So we have detection, it is SLI driven, freshness drift, and success rates, not just the CPU. Classification tags scope and business criticality and selects the runbook. Containment trips breakers, diverts traffics to last known good slices, and shred non critical loads. Remediation kicks off self healing, re enqueuing idempotent stages with jitter retries. Compacts small files if that's the cause, and restart targeted tasks instead of whole. Recovery resumes from checkpoints and passes a consistency validation gate, like the schema, row counts, and spot queries. So before we lift any stale banners, a concrete example. So an AWS S3 cross-region replication lag. Freshness monitors flagged timestamp drift beyond budget, and we paused downstream joins, served the last consistent slice with a new clear stale data banner, and diverted non critical workloads. When replication recovered, we validated consistency on boundary tables, burst scaled or clear the backlog, and returned to steady state. Because the playbook was predefined and on call, only approved steps, everything else was automated. So, the metrics we cared about most was MTTR, first time success rate, P95 query latency, and auto resolution rate, and freshness, data quality error rate, and overall system uptime versus a 99.9% target. Watching these together is what lets you act proactively. For example, a rising DQ error rate paired with stable compute such as schema drift, not capacity, A widening P95 with flat volume suggests partition skew or small file bloat. So if you're adopting this, here's a practical blueprint. So foundation, where defined SLIs and error budgets, set up cost cloud authentication, and build a unified monitoring fabric, and be explicit about your consistency model. When is slightly stale acceptable and for how long? And then for reliability, put circuit breakers at every integration scene. Configure auto-scaling policies with burst windows and add checkpoints at all handoffs and gate promotions to gold through validation. And schemas, row counts, and sampling and freshness. For performance, tune shuffles and partitions, implement Z order from real query patterns, enable dynamic allocation and targeted caching only where hit rates justify, and schedule small file compaction with the thresholds. For example, compact when average file size is less than 128 MB. And for operational, codify the runbooks, automate the top three remediations, hold blameless reviews with action items, and drill cross stream on two failures modes per quarter. So, my key takeaways are one, at this scale, SRE is not optional, it's the backbone. Two, automate recovery to slash MTTR and on call fatigue. Target more than half of the incidents to be self healed. Three, optimize for your access patterns. So, Z order and storage layout choices deliver outside spins. Verify with query logs, not intuition. And four, cross cloud only works with intentional contracts at the seams. That is how you prevent cascades and keep costs predictable. So thank you for listening. And in Q&A, I'm happy to unpack how we picked Z-order keys from query logs and extract freshness SLI thresholds we used and why, and or the conditions that trip our circuit breakers, including the grace periods and hysteresis that prevent flapping. Thank you.